In this video, we're going to look at a quick and easy method to find the vertical asymptotes of a cosecant graph given an equation. So the big idea here is that we're going to apply the horizontal transformations to the vertical asymptotes of the parent graph y equals cosecant x. Okay, so looking at the general form of a cosecant equation, the horizontal transformations are going to be those inputs of the cosecant function. So in the box here, bx minus c. It's whatever's within the parentheses. Those are the inputs that you want. So that's the first part. And then we're going to set that equal to the vertical asymptotes of the parent graph cosecant. So if you aren't familiar with where those parent asymptotes are, take a look at the graph of y equals cosecant x now, and you'll see that they happen at 0 plus pi k. All right, so here's what it looks like together. We're setting those horizontal transformations, or those inputs of the cosecant function, equal to the parent asymptotes 0 plus pi k. Once you have that, it's very simple. All you have to do is solve for x. Now, if you aren't familiar, k is an integer here, and depending on which integer you substitute in to your final equation, you'll get a different vertical asymptote along the graph. So the equation as a whole represents all the asymptotes for your cosecant graph, and then you can find individual ones depending on what value you substitute in for k. So it takes a little bit of getting used to, but it is a really nice, efficient, and concise way to represent all those asymptotes. Now that we know the concept and what we're trying to accomplish, let's try this out with an example. So say we wanted to find the vertical asymptotes for this equation, y equals 3 cosecant of 2x minus pi over 4 plus 1. So to get everything set up, we take the inputs of our cosecant function, that's here, so 2 parentheses x minus pi over 4, and we're going to set that equal to those parent asymptotes of cosecant, and those are 0 plus pi k. Now that we have the setup, all we need to do is solve for x. So with this setup, it makes the most sense to divide both sides of the equation by 2 first. So we divide by 2, make sure you divide every term by 2. On the left, we have x minus pi over 4, and on the right, we have 0 plus pi over 2k. And now we can finish up by adding pi over 4 to both sides. So adding pi over 4, notice that we're only adding pi over 4 to 0 here. The pi over 2k is not a like term to that one, so it kind of stands on its own. All right, now we're left with x equals pi over 4 plus pi over 2k. This is our asymptote generating equation. And you'll get every single vertical asymptote for this graph, depending on what you plug in for k. So before we look at the graph, let's test this out. Let's substitute in a few different values for k. I usually like to start with k 0 just because it's a very easy calculation. You can see when we let k equal to 0, we should end up with an asymptote at x equals pi over 4. So we'll look for that in the graph in just a minute. All right, let's say we let k equal 1. You can see we'd have pi over 4 plus pi over 2. Okay, so if you want to write that out, do a little scratch work. We have pi over 4, and let's rewrite pi over 2 with the common denominator. So it's 2 pi over 4. And we can see we should have an asymptote at 3 pi over 4. Just for good measure, let's do one more. Let's do k equals negative 1. Okay, so we've already kind of done some work here, but let's look at the calculation. We have x equals pi over 4, and k is negative 1 here, so we end up with negative pi over 2, or minus 2 pi over 4. And we should expect another asymptote at negative pi over 4. A great thing to notice here before we move on is that each of these are separated by pi over 2, and that comes right back from the equation, that plus pi over 2k. That's the difference between each of these terms, so that's a neat thing to notice as well. All right, so now that we know a few asymptotes that our asymptote generating equation gets us, let's look at this graph. So here's the graph, and here is the asymptote generating equation. And you can see some of the asymptotes that we predicted are here. We said when k was negative 1, we got negative pi over 4. When k was 0, we got pi over 4. And when k was 1, we got 3 pi over 4. So you can see as you progress, as your k's increase, you should be getting the asymptotes moving to the right. And as your k's decrease, you'll be getting the next one to the left. So try it out, substitute in a few more values for k until you feel really confident with using this equation. And once you do, it makes your life so much easier. It's a great way to find the asymptotes, but also if you're graphing, you can use this to double check your graph and make sure that it's accurate when you finish. Be sure to check out the video description. I'll put some links in there, maybe one more example of finding asymptotes of cosecant graphs, but I'll also post some links for a graphing method that you can use for cosecant graphs and lots of worked examples. So check those out, and thanks for watching.